Okay, we're going to take a look at solving a linear system by the addition method, sometimes referred to as the elimination method. And again, here we have our linear system. Okay, it's the two equations of two lines. If we notice here, this one is a little more complex than the last example, if you guys saw that example, because we see here that 3x and 4x do not contain opposite coefficients, as well as y and 2y. So we are challenged in this problem to make opposite coefficients. It's a very procedural type thing, so we're just going to work these steps over here. And step 0 is to multiply one or both equations by a constant to create opposite coefficients, which we need to do here because we said we do not have them. Okay, well, the one thing I see here is that that y in the top equation is 1y. It's not so easy to turn 3 into negative 4 or turn 4 into negative 3. So let's look at this second set of equations, and we see here if this in fact is a 1, that I could probably turn that 1 into a negative 2 by multiplying the top equation by negative 2. Now, why would I want to turn that into a negative 2? Because the main key to doing the addition method is to make sure you have opposite coefficients. So by changing this term into negative 2y, it will in fact cancel this term of 2y. So let's write the result of that. Most careful thing you need to do here is make sure you distribute correctly, as well as multiply both sides of the equation by whatever constant you chose. Again, in this case, it was negative 2. So I'll just line that up to the bottom equation, and we'll go on to the next step, which is add the equations together to eliminate a variable. And again, we're going to just add straight down, and we will do that and get as a result 4x and negative 6x added together is negative 2x. These in fact cancel these terms because they're opposites, and then 0 plus 2 equals 2. From there, I will go to the next step, which should be pretty obvious. It's solve for the remaining variable. I'll do that by dividing both sides by negative 2 and getting x equals negative 1. My next step now is to plug that value in either one of the original equations. Well, I will choose to plug that into the bottom equation. Not that it really matters, I could do either. Let's just take a look at plugging that in on bottom. So I will get 4 times x, which in this case is negative 1, plus 2y equals 0. Now I'll just start to simplify. Negative 4, rewrite the rest of my line. Oh, excuse me, I should have made the statement here that I'm now solving for the other variable. So now I will add 4 to both sides. And when I do that, I will get 2y equals 4. And then I will divide by 2 and get y equals 2. Now from there, I will need to write the answers in ordered pair. So I have that x is negative 1 and y is 2. So I will in fact write my answer as negative 1, comma, 2, and circle it. That is my answer. Solve it by graphing, which if I were to take a look at that, would love to just quickly demonstrate that if I were to take the top equation and put it y equals mx plus b form, I would get this, and the bottom equation, if I put y equals mx plus b form, I would get that equation. equation of y equals negative 2x. I would make the graph by going to negative 1 on the y-axis and then applying the slope of negative 3. Similarly here, I have a y-intercept of 0 and applying a slope of negative 2. But in fact, it's pretty obvious to see that the point of intersection is negative 1 comma